Welcome all. Myself K. Sirisha, working as assistant professor in mechanical engineering department in MBR College of Engineering and Technology. Today we are going to discuss about the topic of assignment. So what is assignment? The assignment problem is a particular case of transportation problem in which objective is to assign a number of tasks to an equal number of facilities. Okay, if number of tasks is nothing but jobs is equal to the facilities, so jobs is equal to facilities, we can definitely both are make equal. So what are the difference between the transportation problem and assignment problem? In transportation problem and assignment problem, so in transportation problem, supply at any source may be positive quantity ai, and demand any at any destination may be any positive quantity, one or more source to any number of destination. That's nothing but one source or many destinations, whatever it may be. But in assignment problem, supply at any source, nothing but missions will be one only. It has maybe positive value only. We can more than one we can take, but in assignment we can take only one. And demand at any destination will be one, and bi is equal to nothing but one. Here it is a positive quantity we want only, so not to take only the one value, nothing but our supply is not to equal, supply is one, not to equal demand is equal to one. It can more than one value. Here also demand in more than one value, but the values we can, it makes a positive values, not to get any negative values. So more than one value we have the supply, more than one value we can achieve the demand. But in assignment case we will achieve only one supply and one demand, so at that time both are equal, we get the assignment. So otherwise we will not get an assignment. Okay, so here one or more sources to any number of destinations, one or more sources to any destinations, but here one source to only one destination, so one is equal to one, so one source to one destination. But one or more source, if source is one but destinations are many, so that is the problem of transportation. But here only one source and one demand, so that is nothing but assignment. Here we use more than one for supply, for demand, that is nothing but one source many destinations, so that we can achieve the transportation problem. But in an assignment problem we can achieve only one supply and only one demand, not more than one. Okay, so if supply is equal to demand, nothing but both are having the equal values, at that we get the assignment. Okay, so one source to only one destination, so one mission to only one job. Okay, here one mission more jobs, otherwise one job more missions, whatever the, so that is the transportation, that is the assignment. Okay, this is the algorithm, assignment algorithm or Hungarian method. So these problems are very important. Hungarian method. First of all, what is that? First check whether the number of rows and number of columns are equal. So first we can check if the number of rows or number of columns are equal. If it is at that both are equal, we called it as a balanced. Then proceed to, so number of rows and number of columns are equal, then we call it as balanced. Then after we will go for step one. What is step one? If it is not balanced, then it should be balanced for before applying algorithm by adding. So if it is not balanced, we can add a dummy row and dummy column. Then after we will be balanced at the assignment problem. And next, if it is balanced, then if it is balanced, so subtract the smallest cost of, so what is the step one? So the step one is nothing but, so first we will check number of rows or number of columns are equal. So if it is not to step one, so if number of rows or number of columns are equal, if it called as a balanced. If it is not balanced, we can add dummy row and dummy column. After it is balanced, so what is the first step? The first step is we can subtract the smallest value in each row. So the next, we can subtract the least value in each row, that is a step one. And next step two is we can subtract the smallest value in each column. That is mean in each column a resulting material appeared like a step one. Okay, so that is the meaning of, so what is the step one is nothing but, so subtract smallest cost element of each row from all elements in the row. So after that of given cost matrix such that each row contains at least one zero. So if you are doing the problem, you can understand it. So next, the same wise, column wise, and next step 3, assigning zeros, that is the step 3. So if you select row wise column and cancel the vertical, and if you select vertical wise and cancel the column wise, row wise. So when we are doing that problem, we can understand the steps. So after that, we are going to, after that we check it is optimized or optimized or not. So if it is examine the column successfully under okay, what are the, so next we will apply the optimized and get the answer. So when we do the problem, you will understand very easily. So this is our assignment problem. This is our assignment problem. So first we solve the, so solve the assignment problem for maximization of the problem. Why underline this maximization? So if the maximization given in assignment problem, so definitely you will be convert it will in the form of minimization type. So how to convert first step for not like a first step. So first of all, we have to check whether it is balanced or unbalanced. So first we have to check the balanced or unbalanced. So this is a given problem. So first what we check, we have to check number of columns or number of equal to number of rows. So we have number of rows are 1 2 3 4 and column 1 2 3 4. So m is nothing but rows, n is nothing but columns, m is equal to none. So that is a balancing problem. So we know we need not add dummy row and dummy column, because it is a balanced assignment problem. So first the problem is converted into minimization. Why we converted into minimization? Our problem given in the form of maximization type. So in our assignment problem, definitely we have to convert the maximization into minimization. After that, you can solve the problem. Otherwise, we will not get any answer. So that is a main. Okay. So first we will check m is equal to n. Then after you will check whether it is a maximization or minimization problem. If it is a maximization problem, you will be converted in the form of minimization. If the problem given in the form of minimization, so no need to change our problem. So directly you have to do the problem. So first of all, we will check it is a maximization or minimization type. It is a maximization type. So if it is a maximization type, you will be converted in the form of minimization. So how we would like to convert maximization to minimization? So we will select the highest element in the given matrix of all elements. So it is a matrix. We will select in the given matrix of all elements. So 51, 53, 54, 50, 47, 50, 48, 50, 49, 50, 48, 50, 49, 50, 60, 61, 63, 64, 60 and 60. Okay. So here we will select the highest element in this matrix. So 51, 53, 54, 50. So 47, 50, 48, 50, 49, 50, 60, 61, 63, 64, 60, 60. So in all these elements of given matrix, we will select the highest element. So 64 is the highest element, and this highest element is subtract of each element. So 64 minus 51, 64 minus 53, 64 minus 54, 64 minus 50, 40, 67, 64 minus 47, 64 minus 50, 64 minus 48, 64 minus 50, 64 minus 49, 64 minus 50, 64 minus 60, 64 minus 61, 64 minus 63, 64 minus 64, 64 minus 60, 64 minus 60. So the given matrix, the matrix changed in the form of, so this is a minimization, minimize matrix. It is minimized. Okay, it is minimized. So when it is converted into minimized form, so 13, 11, 10, 14, 17, 14, 16, 14, 51, 14, 43, 10, 44. Okay, so what is the first step? So we will follow steps. Okay, so we have I think we have created one doubt. So what is that? If maximization is not mentioned in the given problem, we will directly follow the steps only. If the mention it is a maximus, we will be convert in the form of minimize. When until it is not mentioned, we will directly follow the steps only. Okay, so first step is select the least value in each row and subtract in all the values. So here what are the, so in this matrix I will write here. So this is a matrix. So I will select in each row, I will select the least value in each row. So 13, 11, 10, 14, minimum value is 10. 17, 14, 16, 14, minimum value is 14. 15, 14, 4, 3, minimum value is 3. And 10, 4, 4, minimum value is 0. Okay, so these are the minimum values of minimized matrix. So I will subtract 0 minus 13 minus 10 3, 11 minus 10 1, 10 minus 10 0, 14 minus 10, this is 10 not 0. Okay, this is 10. Okay, so 14 minus 10 4. Next 17 minus 14 3, 14 minus 14 0, 16 minus 14 2, 14 minus 14 0, and next 15 minus 3 12, 14 minus 3 11, 4 minus 3 1, 3 minus 3 0. At the same 1 minus 0 1, 0 minus 0 0, 4 minus 0 4, 4 minus 0 4. Next step 2, set the least value in each column by using it subtracting the remaining in each column. Okay, so likewise in the same way, likewise in the, so this is the matrix I will take here. So 3 1 0 4 3 0 2 0 12 1 12 11 1 0 1 0 4 4. So at the same way in each column I will select least value in each column. So 3 3 2 1, least value is 1, 1 0 11 0, least value is 0, 0 2 1 4, least value is 0, 4 0 0 4, least value is 0. So I will subtract each value. So 3 minus 1 2, 3 minus 1 2, 2 minus 1 1, 1 minus 1 0, and next 0, 1 minus 0 1, 0 minus 0 0, 11 minus 0 11, 0 minus 0 0, 0 minus 0 0, 2 minus 0 2, 1 minus 0 1, 4 minus 0 4, 4 minus 0 4, 0 minus 0 0, 0 minus 0 0, 4 minus 0 4. So likewise, now our third step is not reduction. So column scanning or row scanning. So column scanning and row scanning are very important, not reduction, scanning. So column scanning and row scanning. So what is column scanning and row scanning? So first we will start with the column scanning, then after we will start with column scanning. So what is row scanning is that, so those are all the steps what we studied previous. So what is row scanning? So first we will take the first row. So this row will have only 1 0, not more than 2 zeros we will not consider. We will consider which is the row it has only 1 0. So in this row we have only 1 0, we will consider and mark it and rectangle. So that is only the row wise. First we start with row wise. So it has only 1 0, not if more than 2 0 not considered. If it is only 1 0, we will just and rectangle, we will take in row wise, and if we have any zeros in that particular row of that column, just cancel that 0. If there is no any 0, that just cancel that vertical wise. Take the row wise and cancel that vertical. Okay, and next check the another row. Here we have 2 zeros, so we are not considered. Only 1 0 we will consider. We have 2 zeros, we will not consider. It is not applicable for row scanning. And next we will check another row. 1 11, this is cancelled, and 0. This row have only 1 0 and 1 0, and this and rectangle, this is 0, and just cancel this vertical wise. Okay, row we will when we consider row wise, and just cancel this vertical wise. And next check the another row. This is this having more than 2 zeros, this is not, and check another time also. First start with the first row. So in this row there is no zeros. In this row there is because it is cancelled. Because it is cancelled, this row has 1 0, and triangle this. If they have any 0 in vertical wise, and just cancel this 0 and strike off this column. And next check the another row. This has only 1 0, and rectangle this, and there is no any 0 for vertical column, and just cancel this, Now we have how many and rectangle zeros? 1 2 3 4. And rectangle zeros are 4, and number of rows and number of columns, nothing but number of rows and number of columns are 4, and rectangle zeros are also 4. That is our solution is optimized. Now you take the values of jobs are 1 2 3 4, and matrix P Q R S. Okay, P that is nothing but fourth value. That is not in P. That is what is the fourth value of exact? That is 1. So that is profit is 1. And next Q, that is second. That is Q. Sorry, this is 63. Okay, this is 63. This is 63. And next, and this is 50. Next R. In R, in this position R is 54. And next S in this position is 3 is 61. Okay, so now we add all. So 4 5 5 plus 3 8. And next 10 plus 12 22 228. So answer is 228 rupees. Finally we got the answer of 228. So first we will check only with the row scanning. If it is not take the answer, then after we will go for column scanning. So if it enough for row scanning, not to go for column scanning. If it is not enough for row scanning, then after we will go for column scanning. Whatever, finally we got the answer. So if maximization is mentioned, so definitely have to convert in the form of minimization. Then after you will follow the steps. Step 1, step 2. So step 1 is select the least value in each row, and next step 2 is select the least value in each column, and third step is row scanning or column scanning. So finally we got the solution 228 rupees. So optimization cost value is 228 rupees. Okay. Go for another problem. So that is, the owner of a small machine shop has 4 machines, 1 2 3 4, and available to assign jobs for the day. 1 2 A B C D E. 5 jobs are offered with expected profit for each machinist. So each machine we get the expected profit. So on each job follows assign machinist to jobs, which results in overall maximization profit. Here the hint is given is maximization in the form of maximization profit. So definitely we will be change in the form of minimization. How to change the maximization into minimization? So we will select the highest value of all elements in the given matrix and separate this highest element of all elements. So then after it will be converted in the form of minimization. So then after we will follow the steps 1 2 3. Okay, so here first of all we will check it is a balanced or unbalanced. So here missions are 1 2 3 4 missions, but jobs are 5. So number of rows or number of columns. So rows are 1 2 3 4, but columns 1 2 3 4 5. So number of rows and number of columns does not equal. So it is an unbalanced assignment problem. So what to do? The given assignment problem is maximize step, hence convert in the form of minimize, and also it is not a balanced. So we add dummy matrix M5 to square matrix. So if you add dummy matrix M5, so 5 rows 1 2 3 4 5 rows, and columns 1 2 3 4 5 columns. So so it is M is equal to N. So it is a balanced assignment problem. Next, and we will now we will convert maximize to minimize. So select the highest value in the above matrix. It is so in this all elements, which is highest element? 61. So 61 is the highest element. So 61 is the highest element. Now subtract 61 from all elements in the matrix. So this is the element. So 61 minus 12, 61 minus 28, 61 minus 0 is 61, 61 minus 51, 61 minus 32, 61 minus 12, 61 minus 34, 61 minus 11, 61 minus 23, 61 minus 9, 61 minus 37, 61 minus 42, 61 minus 61, 61 minus 21, 61 minus 31, 61 minus 0, 61 minus 14, 61 minus 37, 61 minus 27, 61 minus 30. So we subtract the highest element of all the elements, and here we mentioned 5 mission 5 also. So 61 minus sorry here. So 61 minus 0, 61 minus 0, 61 minus 0, 61 minus 0, 61 minus 0. So first we select the highest element of in this given matrix, that is 61, and this 61 we can subtract. So first of all here we can add this, we can add the extra omission, that matrix will be changed in the form. So then after we will the maximize to minimize. So subtract 61 minus 12, 61 minus 28, 61 minus 0, 61 minus 51, 61 minus 32, 61 minus 12, 61 minus 34, 61 minus 11, 61 minus 23, 61 minus 9, 61 minus 37, 61 minus 42, 61 minus 61, 61 minus 21, 61 minus 31, 61 minus 0, 61 minus 14, 61 minus 37, 61 minus 20. So after that we will get in the form of minimization form. So we will follow the steps, that is step 1. So for the step 1, select the least value in each row and subtract this value in row. So here in this row least value is 10, in this row least value is 27, in this row 24, 19, 0, 40, 30 least value is 0, 61, 47, 24, 34, 31 least value is 24, 61, 61, 61, 61, 61 least value is 61. So now we subtract this element in each row. So 49 minus 10, 33 minus 10, 61 minus 10, 10 minus 10, 29 minus 10. So 39, 23, 51, 0, 9, 10. And next 49 minus 27, 27 minus 27, 50 minus 27, 38 minus 27, 52 minus 27. So 22, 0, 23, 11, 25. And next it is 0, 24 minus 0, 19 minus 0, 0 minus 0, 40 minus 0, 30 minus 0, 24, 19, 0, 40, 30. And next 2, 24, 61 minus 24, 47 minus 24, 25 minus 24, 34 minus 24, 31 minus 24, that is 37, 23, 0, 13, 10, 7. And next 61, 61 minus 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 61. So those are all 0. And next we will follow the second step. That second step is select least value in each column by using subtract the remaining value in each column. So that is in this matrix, select the each column minimum value. In this column 0 is minimum, 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 in this column 0 is minimum. So in this, so 39 minus 0, 22 minus 0, 44 minus 0, 37 minus 0, 0 minus. Likewise 23 minus 0, 0 minus 0, 19 minus 0, 23 minus 0, 0 minus 0. At the same way, 51 minus 0, 23 minus 0, 0 minus 0, 0 minus 0, 0 minus 0, 0 minus 0, 11 minus 0, 40 minus 0, 10 minus 0, 0 minus 0, 19 minus 0, 25 minus 0, 30 minus 0, 7 minus 0, 0 minus 0. So finally got in the form of 39. So 39, 22, 24, 37, 0, 23, 0, 19, 23, 0, 51, 23, 0, 0, 0, 0, 11, 40, 10, 0, 19, 25, 37, 0. So first step is column wise. So select the each value in each row least value, subtract this value in each row. At the same way, next step is column. So next column select the least value in each column and separate it remaining value. Okay, so finally we got this matrix. So our third step is row scanning or column. So take this matrix as like here, as like here. Now I select. So first the third step is row scanning or column. So first I start with row scanning. So in this row scanning, so each row we will have only one zero. If it is more than 2 zeros, it is not eligible for row scanning. So first we select this row. In this row we have only 1 0. So I unrectangle this 0. So I unrectangle this 0. So in this if it is have any 0 in this column, I just cancel this 0 and strike off this column. Okay, next I check the we will start only row. So first row is completed. I will go for second row. In this second row also I have only 1 0. Just unrectangle this 0. I will check in this column wise if I have any 0. So I have 1 0. Just I will mark this. So I will cancel that B column. And next I will check another row. In this row also have only 1 0. Only 0 wise. In row wise I have only 1 0, but I will check the column wise. In this column wise I have 2 zeros. So I cancel these zeros and cancel this entire column C. Next I will check another row. In this row they have no any zeros, and I will check this row. I have 2 zeros, so this is not eligible for row scan. Next I will start with the first row. So in this first row there is no any zeros, and second row there is no any zeros, and third row there is no any zeros, and fourth row there is no any zeros, and fifth row there is no zeros, because we have 2 zeros. It is not eligible for rows. Now it is completed for row scanning. Then I will go for column scanning. In column, if it is completed, there is no any chance, so there is no chance for row scanning, so we will go for the column scanning. So I will go for the column scanning. In this column scanning also have only 1 zero. If it is more than 2 zeros in column, it is not eligible for column scanning. I will check the column. I will check in each column, and it has only 1 zero. So in this column I have only 1 zero. I will unrectangle this 0. If any I will unrectangle 0. If any 0 in row wise, so if I can check the column wise, I will check. If I take the column wise, I will check the row wise. If I take the row wise, I will check the column wise. Now I'm going for column scanning, so I will check the row wise. I will check the row wise. Here only 1 0. Just cancel this and cancel the M and strike the M5. Next I will go for the another column. Here there is no any 0. Here there is no any 0. Here there is no any 0, and here there is no 0. Now I will add how many number of unrectangle zeros. 1, 2, 3, 4. Our unrectangled zeros. Unrectangled zeros are 4. But our number of rows and columns 5. So M is equal to N is equal to 5, but those are not equal. So that is meaning of there is no any optimal solution. So if it is both are equal, at that we will get the optimal solution, get the maximum profit. Here there is no any, we will not get any optimum value or maximum value. So what should we do? Next we will, so if the problem we will like that, so I will go for step 4. If the problem is ended, the problem end with step 3. But our M is equal to N is equal to 5, but N rectangle zeros are 4. Our solution is not optimized. So what we should do? We will go for step 4. So how to do step 4? So here unallocated cells. So strike of the cancelled values are not unallocated. So which elements were called as unallocated? 39, 19, 22, 25, 24, 30, 37, 7. So those elements we called as unallocated cells. So we will select. So apply optimum analysis identity, least cell value, that is unallocated cells. So minimum of 39, 19, 22, 25, 24, 30, 37, 7. So in this unallocated cell, take the minimum value. In this unallocated set, take the minimum value is 7. So 7 is subtract from all uncovered cells and add at a junction. So what is the junction? So junction is nothing but, so here junction is nothing but when it intersects. So this is we called as, so when we get the plus mark, that is we called as junction. So this is also plus mark, this is also plus mark, and this is also plus mark, this is also. So when we will get the plus mark, that we call that element we called as a junction. Okay, that element we called as junction. So subtract unallocated cells in subtract unallocated cell in minimum of minimum value and add at a junction. Okay, is 39 minus 7 is, so 32. Unallocated cells is 39, and 23 is as is, because of this is not unallocated cell. 51 is as is because of this is also unallocated cell, and next 0 is also unallocated cell, but 19 is unallocated. So 19 minus 7 is 12. 19 minus 7 is 12. Okay, only subtract 7 from unallocated cell. Next 22 minus 7 here. So 22. So 22 22 minus 7 is 22 minus 7 is 15 because of it is unallocated cell. So 0 is as it is and 23 is as it is, 11 is as it is. Unallocated cell is 25. So 25 minus 7 is 18. Okay, and next 24, because of 24 is unallocated cell, 24 minus 7 is 24 minus 7 is 17, and 19 is asterisk because of 19 is not allocated cell. 0, 40 is not also not allocated cell. 30 minus 7 is 23. Okay, next M for mission. 37 minus 7 is 30 because of 23 is unallocated cell asterisk, and 0 is also not unallocated cell. 10 is also not unallocated cell. 7 is allocated cell. 7 minus 7 is 0. Okay, next for mission 5. In mission 5 we have zeros. We have plus mark. That is we call as junction. We have plus mark. If we have any plus mark, just add 7. 0 plus 7 is 0, and here also we have plus mark, that is 7. Sorry, this cell here, this cell is not in a plus mark because of this is not in plus mark. Okay, this is a table, and just cross. So this is plus mark because of this line and this line. This is plus mark. Okay, this is have one plus mark, and this line this has another plus mark, and this line and the horizontal vertical and another plus mark. So 0 here, 0 plus 7. When we are getting the plus mark, that we call as junction. 0 plus 7 7, 0 plus 7 7, and 0 plus 7 7, and this is only we got 0 because of unallocated cell. So finally we got the table like this. And next we will do step 3. We will do the step 3, that is row scanning or column scanning. So we will do row scanning or column scanning. So start same. So finally we do the row scanning and column scanning. Row scanning and column scanning. So first we will start with row scanning. So here we have only single 0. So take 0 as a rectangle and check in column wise. Here any 0? No. So just cross this. Just strike off this, and next go for another row. Here only 1 0 and rectangle this 0. If there any zeros in column wise, no. So just cross this. And next go for a mission 3. Here only 1 0 and just rectangle this. Is there any 0? Yes, 1 0. Calculate the row wise, but check the column wise. 1 0 and just cross this C. And cross this C. And next in mission 4 we have only 1 0. In column wise we have 0, that cancel. So and strike off the E and check this row. Here only 1 0, and if there any 0 here, no, just strike off the E. So here how many rectangles? 1 2 3 4 5. So finally M is equal to N is equal to 5, and N rectangled zeros. And rectangle zeros are 5. And rectangle zeros are 5. So we called here mission M1 for D. Mission M1 for D value is, first we will check. So mission 1 D, mission 2 B, mission 3 C, and mission 4 is E, mission 5 is A. Okay, so here for D is mission 1 D is, so mission 1 D is 51, mission 1 D is 51, And next machine 1 D is 51 and machine 2 B is 34 and machine 3 C is 61 and machine 4 E is 30. Machine 5 A, here there is no any machine, this is machine 5. Machine 5 A is 0. So finally we got the answer of 51 plus 34 plus 61 plus 30 plus 0. We got the answer of 176 rupees. So finally get answer, maximum profit is 176 rupees.